Hi and welcome to this video, which is one of the last videos about benzene chemistry. And in this video what I would like us to do is to produce what is often called an organic tool kit. In other words, to try to put together on one piece of paper the different reactions that we've met about benzene. So here's benzene, she's our starting point. And the picture, when you do it for yourself, looks a bit like a spider diagram or a mind map. So we're going to have different lines coming off benzene, showing the different reactions it can do and resulting in the different products. So I'm just going to put two reactions into my picture of benzene. And then for your assignment, I want you to add in all the others that we have met. So one of the reactions might be going from benzene to some form of acyl products. So on here we might be adding, say, a ketone group. So if I wanted to know about that reaction, I wanted the details of that chemical reaction, then the information I would have to put on here would have to be, what reactant do I need? And the answer is, I would need CH3 COCl, that guy there, called ethanoyl chloride. I also need a catalyst, and the catalyst that I would have to use is AlCl3. Now other catalysts or halogen carriers can be used, such as FeCl3, that's another option, but I have chosen the AlCl3 for my diagram. And I would have to do this reaction under certain conditions, and the conditions I would have to do it would have to be anhydrous. In other words, in the absence of water, which in the UK means that you'd have to do it in dry air, because the air in this country is very damp. And this reaction would then produce that, and it would also release hydrogen chloride as a side product, but I'm not going to put in the side product because I'm only interested in this. Now if I wish to add further detail, I might also add underneath that this is described as Friedel-Crafts acylation. So just on one arrow on my mind map or my toolkit, I get quite a lot of information. The reactant, the conditions, anhydrous and in the presence of a catalyst, and the classification of the reaction. Let's do one more, and this is the one for which you should know the mechanism, which is the nitration of benzene. Now when we nitrate benzene, we produce the nitro compounds with benzene and NO2 on the top of it. Now this chemical reaction requires a reactant, and the reactant that we use is concentrated HNO3, nitric acids. And once again, like we did in the first thing, we think, what is the reactant? Any other information? Do I need a catalyst? And the answer is yes, I do need a catalyst, and that's concentrated H2SO4. By the way, if you put these two chemicals together, concentrated HNO3, concentrated H2SO4, you make a mixture that is will dissolve anything at all. It's called aqua regia, the king's water. The king's water. Let's hope no king was whittling it out. There wouldn't be much left of him afterwards. And then do we need to know any other information? Yes, that this reaction should be done at a temperature of less than 5 degrees Celsius. Otherwise what you end up with is multiple nitrations on the ring, and you end up making things that you really shouldn't make, because they'll probably blow up. Do we call this reaction anything? Do we classify it? Yes, we classify it as nitration. Now, in the activity that I would like you to do today, I would like you to go from this point and using the worksheet to see if you can add any other arrows, and once you've added the arrows, is to add any more detail. So, for example, you could also go from this one to make the secondary alcohol that might look a little bit like this. From this one here, you might be able to go from the nitro compounds to phenylamine. And there are many other arrows that you could put on your picture. Now, I hope that you can see that the point of doing this is that what we're doing is synthesis. We're asking the question, how do you go from a simple starting material to make more and more complex organic molecules, the type of which you want for industry or for pharmaceuticals? This is organic synthesis, and we call this an organic synthesis toolkit, and that's our activity for today.